Fire seems like one of the most obvious things in the universe. Touch it and it burns. Watch it and it dances. Feed it fuel and air and it lives. Take those away and it dies. From childhood, we accept fire as a basic fact of existence, something primitive and self-evident, as if its burning quality were simply built into the universe with no deeper explanation required. But this is exactly where Richard Feynman loved to stop us. Because when you ask, why does fire burn? Really, truly why? You are not asking a simple question. You are poking at the foundations of chemistry, physics, evolution, and even human perception. Feynman's answer doesn't just explain fire, it quietly dismantles the way we think about explanations themselves. At first glance, the usual answer sounds sufficient. Fire burns because it is hot. Heat damages skin. End of story. But this is not an explanation, it's a loop. Why is it hot? Because combustion releases energy. Why does combustion release energy? Because chemical bonds rearrange. Why does that hurt us? Because our nerves respond to damage. Already, the question has slipped away from flames and into atoms, biology, and information. Feynman's genius was not in giving a single dramatic sentence as an answer, but in showing that any honest explanation is a journey across layers of reality, and that no layer is the final one. To understand why fire burns, you must first abandon the idea that burning is some special mystical property of flames. Fire does not burn because it is fire. Fire is a visible side effect of a chemical process, rapid oxidation taking place at the molecular level. When a substance like wood reacts with oxygen, its molecules rearrange into new molecules, such as carbon dioxide, water vapor, and ash. In this rearrangement, energy that was stored in chemical bonds is released. Some of that energy appears as light, which we see as flame, and some as random molecular motion, which we experience as heat. The flame is not the cause. It is the billboard advertising that energy is being dumped into the surroundings. But even this explanation only pushes the question one step deeper. Why does rearranging molecules release energy at all? Why are some chemical bonds higher energy than others? Here we enter the strange world of electrons, electric forces, and quantum rules. Atoms stick together because negatively charged electrons and positively charged nuclei interact through electromagnetic forces. Certain arrangements of electrons and nuclei are more stable than others. When atoms move from a less stable arrangement to a more stable one, energy must go somewhere. In combustion, that energy is violently released into the environment. Fire burns because nature prefers lower energy arrangements, and it collects the difference like a debt being paid in heat and light. Now comes the part that begins to feel unsettling. The fire does not want to burn you. It has no intention, no malice, no awareness. The reason it damages your skin is not because it is aggressive, but because your body is a fragile, exquisitely organized system of molecules that only function within a narrow temperature range. When the energy from the fire floods into your skin, it disrupts the delicate molecular machinery that keeps your cells alive. Proteins unfold, cell membranes rupture. Chemical reactions that should happen slowly happen all at once or not at all. The sensation we call pain is your nervous system screaming that its structure is being destroyed. And here is where Feynman's answer begins to shatter everyday intuition. Fire does not burn because it is hot. Rather, hot is our word for what happens when enormous numbers of microscopic particles move and collide with enough energy to tear apart biological structures. Heat is not a substance. It is not a fluid. It is a statistical description of motion at scales far too small to see. Fire burns you because trillions upon trillions of atoms are slamming into your atoms with enough violence to break the patterns your life depends on. But even that is not the end. Why does broken molecular structure feel like pain instead of just nothing? Pain is not a property of fire, it is a product of evolution. Over millions of years, organisms that could detect damaging conditions and react quickly were more likely to survive and reproduce. Fire existed long before pain did. The universe does not care whether something burns, but living systems that learn to care avoided destruction. What you experience as burning is your brain interpreting electrical signals sent by specialized nerve endings that evolved precisely to warn you this energy will kill you if you don't pull away. So when we say fire burns, we are secretly compressing an absurdly long chain of facts. We are mixing physics, chemistry, biology, and subjective experience into a single misleading statement. Fire releases energy because of electromagnetic forces and quantum rules. That energy disrupts molecular structures in your skin. Your nervous system detects that disruption. Your brain translates those signals into agony. None of these steps is obvious. None of them is contained entirely within the flame itself. Feynman loved to point out that explanations are not things you either have or don't have. They are things you choose the depth of. You can explain fire burning at the level of everyday language. It's hot. You can explain it at the level of chemistry. Oxidation releases energy. You can explain it at the level of physics. Electromagnetic interactions rearrange electrons into lower energy states. Or you can explain it at the level of human experience. Our evolved nervous system interprets molecular damage as pain. None of these explanations is wrong. They are simply answers to different versions of the same question. What shatters reality is realizing that there is no ultimate, final explanation waiting at the bottom. If you keep asking why, you do not arrive at a cosmic label that says fire burns because X. You arrive at more fundamental rules, and then rules beneath those, and then mathematical descriptions that tell you how things behave without ever telling you why in the human sense. At the deepest level we currently know, particles follow probabilistic rules. Fields interact. Constants have the values they have. And that is where physics, at least for now, must stop and say, that's how nature behaves. This is deeply uncomfortable for the human mind. We want purpose. We want intention. We want a story. Fire feels dangerous, so we imagine it as an active threat. But in reality, fire is just the universe doing what it always does, moving towards lower energy configurations according to impersonal laws. It is no more cruel than gravity when you fall, or radiation when it damages DNA. The universe does not burn you, it simply does not protect you. Feynman's answer quietly destroys another comforting illusion, the idea that our everyday experiences are fundamental. Burning feels basic because we evolved at a scale where chemistry and biology matter. But from the universe's perspective, your pain is an emergent side effect, not a central feature. If humans did not exist, fire would still release energy, wood would still oxidize, flames would still glow. Burning would not exist as a concept at all. Even the color of fire, which we often associate with heat, is another layer of illusion. Flames are not inherently orange or blue. Their colors come from excited atoms and molecules emitting light at specific wavelengths when electrons jump between energy levels. Sodium produces yellow, copper produces green or blue. The color tells you about the atomic transitions taking place, not about how hot the fire feels to human skin. Again, what seems simple is revealed as a coded message from the quantum world. The more you follow Feynman down this path, the more the original question dissolves. Why does fire burn? Because of electrons. Why do electrons behave that way? Because of quantum electrodynamics. Why does quantum electrodynamics work? Because that's the theory that best matches experiments. Why does the universe obey that theory? At some point, science can only answer, this is the rule book we observe. The need for a deeper why becomes philosophical, not scientific. And yet, this is not a defeat, it is a liberation. Feynman never saw the lack of ultimate answers as depressing. He saw it as beautiful. The fact that such a familiar thing as fire connects you to the deepest laws of the universe is astonishing. When you watch a flame, you are watching electrons rearrange themselves according to quantum rules discovered through decades of human curiosity. When you feel heat, you are sensing the chaotic motion of atoms. When you feel pain, you are experiencing the legacy of billions of years of evolution compressed into a nerve impulse. So, when fire burns your skin, it does not just burn your skin, it burns away naive explanations. It forces you to confront the layered nature of reality. There is no single story that captures everything. There are only models, each useful in its own context, each incomplete in a deeper one. Fire burns at the level of chemistry, destroys at the level of biology, and teaches humility at the level of philosophy. That is why Feynman's answer feels like it shatters reality, not because it replaces a simple idea with a complicated one, but because it reveals that simplicity itself is a convenient